guys, I hope the first round of substitution method went well. I'll be looking at your problems here pretty soon. But let's take a look at what happens when you have these true-false cases when you're doing the substitution method. Remember, in one case, you have two lines that could cross. That's consistent, independent. Or you could have two lines that are parallel, that's inconsistent. Or you might have two lines that are in the same place. Now, when you graph, that becomes pretty obvious. But when you're doing substitution method, you might not realize it until you get down to the end of the problem. So here we go. Substitution method. Remember, you have to start by getting x or y alone in one of your equations. So if I'm looking at my two equations here, I think that this x is probably the easiest thing to isolate. All I need to do is add 2y to both sides. So I'm going to keep that equation. So this would be 3 plus 2y. Then I'm going to take the other equation and put it over here. Okay, then here comes the substitution part. If it says x equals, then that means this stuff is equal to x, and you can replace it in your equation where the x is. So I'm going to put parentheses, 3x plus 2y plus 4y equals 15. So we solve like normal, because look, we don't have x and y anymore, we just have y. So if at this point you still have x and y, then you know you put it in the wrong place, okay? Right? And then combine your like terms here. So we have 15 plus 14y equals 15. And subtract 15 on both sides. So 14y equals 0. Divide both sides by 14. And y equals 0. Now, this is not a special case. This just means that y equals 0. So in our solution, the y value is 0. So I got to plug that back in here for y and find out what my x value is. Okay, so we have x equal to 3. Okay, so that is your x value. Okay, so this would mean a case where you have these two lines crossing. So you have something kind of like this, and they would have a solution at 3, 0. This would be consistent, independent. All right, let's look at the next one. So we have to get x or y alone. Let me get my separator here. I'm going to pick this x right here, so I'm going to add y to both sides. That means that x would equal 1 plus y. I'm going to take the other equation and write it here. Okay, now x equals 1 plus y. So where I have the x, that's where I'm going to put 1 plus y. Okay, distributive property, so 3 plus 3y equals 3y plus 3. Starting to look a little bit peculiar. The y is on both sides. Remember to take care of your variable. We got to cancel one of them out. And it disappears from both sides. That means not y equals 3, not x equals 3, but 3 equals 3. That is a true statement always. So this would be a case where your lines are in the same place because every point that they share is a solution. Okay, so this would be a case that there are infinite solutions. And this would be consistent dependent. Okay? All right, last case here. I bet you know where I'm headed. Let's see here. We have, what are we gonna learn here? Okay, x would be easy. I just have to subtract y, or y. I'm gonna pick y this time. So that means I'm gonna subtract x. So y equals -2 minus x. And take the other equation over here. Get used to this new smart marker word. All right, and then here's your clue. If it says y equals, then this stuff has to go where y is. Okay. Distributive property. Oh, I forgot the 2 here. All right, so 2x minus 4 minus 2x equals 8. And then combine your like terms, which 2x minus 2x makes that disappear. Not what we were planning, but it did. Okay. And we have a case where -4 equals 8. Well, really? No, -4 does not equal 8. This is false, which means that there is no solution for this system. We have parallel lines that would be called inconsistent. Okay, because there is no solution. So you solve just like normal. Okay, and you try to do your normal stuff, but if your variable cancels and it's gone, you decide, is it going to be true all the time, or will it be false all the time? All right.